Okay, so that brings us to the next law, which is called the ideal gas law. But before we go to the ideal gas law, there's another gas law that we need to look at, which is called the Avogadro's law. If you look at this law here, you see volume and you see mole. This makes a lot of sense. For example, let's say if you have a balloon, okay, you have a balloon, and what you do is you add more air inside of the balloon. What will happen? The balloon will get bigger, right? So what, when we're adding air, it basically means we're adding more moles of air, right? So we're basically adding moles of air. That's what we're doing. So when you add more and more particles into a space, the volume will increase. So if you shrink, if you remove the thread here, what will happen is the balloon will become smaller, right? The balloon will become smaller because it starts losing all of the air. So basically all the number of moles is going on, the number of particles are all going on. So that's the relationship between volume and number of moles. So if you remember in the previous chapter, so we had P, V, T, right? So what if we add one more here? So V is on top, N is at the bottom. So basically it looks like that, PV over NT. And this will be same as constant. Now, when you see this word same as constant, what does it actually mean? So basically, to understand this, let's say if you have a room, okay? Let's say you have a room. In this room, you know the volume, you know the pressure, you know the temperature of the room, and let's say you know the number of particles in that room, okay? What you do is you take the ratio of everything. You take P1, you take V1, N1, and T1. You take the ratio, you get a number. So let's say you get a number. So the number is called X. And then let's say you have another room. The room is a little bit bigger. And in this room, the temperature is, let's say, T2. It is V2, the volume. The pressure is P2. And the number of particles is N2. If you decide to take the ratio of all of them, you will get, surprisingly, the value X as well. Okay, you get the same value. So what it basically means is, for any given volume, at any given temperature and pressure, the ratio of the product of pressure and volume divided with the product of moles and temperature will always be constant. It's a number. And this number is actually called R. Okay, so it's called R. So it's R. R is called the universal gas constant. Okay, it's called the universal gas constant. Okay, it's somewhere here in the notes. Anyway, okay, we see here, right? You see, so this is called the ideal gas law. You see the R here. So you see here, okay, this is the R value. It's called the universal gas constant. All right, so this formula is actually capital P, capital PV and RT. So from this formula, we get from this whole concept, we get a formula. This formula is called PV and RT. So this is a very important formula, PV over nRT. So this is called the ideal gas law. Okay, you can see at the bottom here, if you read on later, you can see PV and RT. The value of R, okay, so this is the important part. This is where students get confused. The value of R will be different if pressure is different. So for example, if pressure is measured in kilopascal, then R is 8.31. But let's say pressure is measured in atmospheres. Okay, let's say pressure is measured in atmospheres. Then the R value is 0.0821 kilo. So these two values are given to you during the exam. So you do not need to memorize this. Okay, do not need to memorize this. And one thing just now I saw here, which I would like you to know, is this. Note that standard temperature and pressure, STP, is taken as 0 degrees Celsius and 100 kilopascal. Okay, 100 kilo. So this one, whenever you hear the word STP, please remember it's 100 kilopascal and 0 degrees Celsius. All right. Okay. So now we have this formula already. So how do we use this formula? Very easy. Look at this question here. What volume is occupied by 3.76 grams of oxygen? This is oxygen at pressure of 88.4 kilopascal at a temperature of 19. So if you look at this question, right, first of all, the temperature needed to be converted to Kelvin. So we added this with 273. Second thing is, this is kilopascal. So R is going to be 8.314. Okay. So all we got to do is we plug everything into the formula. So P, V, N, R, T. So we know the value of P, we know the value of V. Okay. Okay, sorry, we don't know. We are looking for the value of V, sorry. All right. But we can, my mistake, we know N, sorry, we know N. N is the number of moles of oxygen. So what you do is, you do this. You take the mass of oxygen given, divide with the molar mass, you get the moles. Okay, so this is the moles. So we know the moles, we know R, we know T. So if you plug everything in, you should be able to get the volume. Quite straightforward, no? So you can also do the same calculation to find molar masses, which is straightforward. A reaction occurs to produce an oxide of nitrogen gas. The gas has a mass of 1.211 gram, occupies a volume of 677, temperature is 23, pressure is this. All we have to do is, first of all, change temperature to Kelvin. Pressure was given to you in atmospheres. R is 0.0821. Very easy. Plug it into the formula and you can get the value of N. This is the value of N. So we know N is mass over molar mass. Yes or no? So if you move this around, you will be able to figure out what the molar mass is. Very easy. Okay. So that's it. So this will be the ideal gas law. So it's easier for you to do this. Okay. Can? Okay, we stop here.